Okay. Now in this example, we have repeated quadratic factors, right? X squared plus 2. This is a quadratic factor, and this factor is repeated. So just like when we have repeated linear factors, we need two fractions. So when we have a repeated quadratic factors, we also need two fractions. So the first fraction is ax plus b over this quadratic factor, and the second fraction is another number cx plus d over x squared plus 2 square. And the next, we need to determine a, b, c, and d. So to combine them, we multiply the numerator and denominator of the first fraction by x squared plus 2. So we can make the denominator be x squared plus 2 square. So I multiply ax plus b by x squared plus 2 and add by cx plus d. Okay, then we simplify the numerator. Therefore, we can compare this numerator with ax cubed plus 13x. So ax times x squared plus ax times 2 and plus bx squared and plus 2b plus cx plus d. So since 8x cubed plus 13x equals ax cubed plus 2ax plus bx squared plus 2b plus cx plus d. Because a is the only coefficient of x cubed. That means a must be equal to 8, and the d is the only constant on the right hand side, and the constant on the left hand side is 0, so d equals 0. Next, we can determine b, because b is the coefficient of x squared, but over here we don't have x squared, so b is 0. And the next, c, because 2ax plus cx equals 13x, and we already figured out a is equal to 8. So this is 16x plus cx equals 13x. Therefore, c is a negative 3. So we can rewrite this into 8x over x squared plus 2 and plus negative 3x over x squared plus 2 over 2. Okay, now let me show you another example before we talk about how to rewrite the rational expression when the degree of the numerator is bigger than the degree of the denominator. Now let's think about what if we have this rational expression. Let's think about how many fractions do we need. So there are two repeated linear factors, right? And 1 repeated quadratic factors. So in total, we need 2 added by 3, so 5. 5 added by 2, so 7. In total, we need 7 fractions. So the first 2 fractions, they are a over x minus 2 plus b over x minus 2 squared. And then we have c over x plus 1 plus d over x plus 1 squared plus e over x plus 1 to the third. And for this quadratic factor, we need, a, b, c, d, e, f. So f x g over x squared plus x plus 1 h x plus I over x squared plus x plus 1 squared, right? So we need these 6 fractions when we do the partial fractions. Okay, now let's look at what if the degree of the numerator px is greater than the degree of the denominator. Now, in this way, we first use a non-division. So we divide px by qx. So we can generate a polynomial. So the quotient is a polynomial, and the remainder gonna be another rational expression, and we use a partial fraction to write this rational expression. So now let me use this example to show this. Let's see, we are looking for the integral of x to the fourth plus 2x cubed plus 6x squared plus 20x plus 6 over x cubed plus 2x squared plus x dx. Now we notice that the degree of the numerator is 4 and the degree of the denominator is 3. So first we use the u substitution. So we divide px by qx. So the first term gonna be x. Why? Because only if when you multiply x by x cubed, you can have x to the fourth. So x is here. So x multiplied by x cubed, we have x to the fourth. And x multiplied by 2x squared, we have 2x cubed. Now x multiplied by x squared, we have x squared. And then we subtract. Remember, we are using subtraction. We subtract this polynomial from the polynomial above. So we have 0, 0, 0. Sorry, this is a 6x squared minus x squared. So this is a 5x squared. And 20x minus 0, so we have 20x. And 6 minus 0, we have 6. Now, after we use the non-division, we rewrite this rational expression into x plus the remainder 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x. So the integral becomes the integral of x plus 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x. And we can split this into these two. We can split this into these two integrals. And for the second integral, use the partial fraction. We said we can rewrite this into now a over x. Now a is we determined here a is 6, so it's 6 over x, and plus b is negative 1, so negative 1 over x plus 1, and plus c. C is 9, so 9 over x plus 1 squared dx. So the second integral, we can split it into these three integrals. And then for each integral, we use the appropriate method. We can find the answer. So we add them together. That will be the answer to this integral. Okay. So this is what we do when the degree of the numerator is greater than the degree of the denominator.